Hello everyone, welcome back to Young Einstein. On our last video, we talked about GP. We took an example of GP that led us to simultaneous equation. So in this video, you'll see how to sum up the terms in a GP, adding the terms in a GP. So before I get into this video, make sure you subscribe, like, and leave comments on other topics you'd like to know more about. So sum of a GP. Sum of a GP. That's the topic for today. That is how to sum up it might be first 5 terms, first 6 terms, in general, first n terms of a series. So we are going to derive the formula for this. If you can remember in the AP video, sum of an AP video, we derived the formula for sum of an AP. So here we are going to derive the formula for sum of a GP. So if you're asked to sum up the first n terms of the series, that's Sn, just like AP. First n, sum of the first n terms represented by Sn. They mean that you should add up the first term, second term, third term, fourth term, fifth term until you get to that number of terms that you're asked to. That is until you get to Tn. Until you get to Tn. The term before you reach Tn is Tn minus 1. I hope you understand what I just said now. The term before you reach Tn. Let's say they say sum up the first 7 terms. Tn in this case will be T7. So the term before T7 is T6, which is same thing as Tn minus 1. Because n minus 1 is 7 minus 1, that's 6. So the term before T7 is T6. That is the same way the term before Tn is Tn minus 1. So if you ask to find Sn, that is the sum of the first n terms. You add the first term plus second term plus third term and so on. So in symbols, you write that Sn is equal to T1 plus T2 plus T3 and so on until you get to Tn minus 1 followed by Tn. That's to add all the terms until you reach Tn from 1 to n. T1 plus T2 plus T3 and so on until you get to Tn. So that's the expression for what they are asking you to do. That is some of the first n terms. Now, from the first video on geometric progression, we said T1 is A, T2 is AR, T3 is A, R raised to the power of 2, and so on. So we substitute this into what we have now. So we have Sn is equal to T1 plus T2 plus T3 and so on. So it will become Sn is equal to T1 will become A, T2 will become AR, T3 will become AR raised to the power of 2. So you have Sn is equal to A plus AR plus AR raised to the power of 2 and so on. Now this Tn minus 1 will become AR raised to the power of n minus 2. AR raised to the power of n minus 2. Because remember, we always reduce the number of terms by 1. The number of terms is n minus 1. When we reduce n minus 1 by 1, that is subtracting 1 again, you get n minus 2. So that's why I have AR raised to the power of n minus 2. Then the Tn will become AR raised to the power of n minus 1. That is normal GP formula. Tn is equal to AR raised to the power of n minus 1. So that Tn will become AR raised to the power of n minus 1. So in general, what you have is Sn is equal to A plus AR plus AR raised to the power of 2. If there are more terms, AR raised to the power of 3, AR raised to the power of 4, and so on until you get to AR raised to the power of n minus 2 plus AR raised to the power of n minus 1. So this is what you have now. Let's call this equation that we have here equation 1. Call it equation 1. Now follow the steps I'm going to follow to derive this formula that I need. So from here now, this is what you will do. You multiply this equation 1 by r. Just follow the step. Multiply equation 1 by r. That is, multiply the right hand side and the left hand side by r. The left hand side is Sn. So multiply Sn by r, you get Rsn. Then on the other side, you have r open bracket, a plus ar plus ar raised to the power of 2 and so on until you get to ar raised to the power of n minus 2 plus ar raised to the power of n minus 1. That's, I put in the r outside because I'm multiplying every term in the bracket by that r. So what I have there is Rsn is equal to r open bracket a plus ar plus ar raised to the power of 2 and so on, ar n raised to the power of n minus 2 plus ar raised to the power of n minus 1 close bracket. So this r that is outside the bracket, I will use it to open the bracket. So the first term in the bracket is a times r, that is outside, will give you ar. The next term is ar times r will give you ar raised to the power of 2. The next term is ar raised to the power of 2. Ar raised to the power of 2 times r will give you ar raised to the power of 3. And so on until that ar raised to the power of n minus 2. When you multiply it by r, you get ar raised to the power of n minus 1. Get ar raised to the power of n minus 1 when you multiply by r. Then the ar raised to the power of n minus 1 as inside the bracket, multiply by r, you get ar raised to the power of n. And let me explain these two last terms that I got. So the second to the last term, that's ar raised to the power of n minus 2. Ar raised to the power of n minus 2. When you multiply by the r that is outside the bracket, now the r itself has a power of 1. Then the r in ar raised to the power of n minus 2 has a power of n minus 2. Based on the multiplication law of indices, you add their powers. This one power is n minus 2. Then r power is just 1. So n minus 2 plus 1, you get n minus 1. So that's why we have ar raised to the power of n minus 1 there. Now on the other part, that is ar raised to the power of n minus 1 multiplied by r. On this side, the r is raised to the power of n minus 1. Then outside the bracket, the r is raised to the power of 1. So you're adding the two powers, n minus 1 plus 1. n minus 1 plus 1. Minus 1 plus 1 is 0. So that's just n. That is r raised to the power of n. That's why we have ar raised to the power of n. So now what we have is rsn is equal to ar plus ar squared plus ar raised to the power of 3, and so on until you get to ar raised to the power of n minus 1 plus ar raised to the power of n. So this is a different equation from equation 1. We call this equation equation 2. So we have two equations. The first equation is Sn is equal to a plus ar plus ar raised to the power of 2, and so on until you get to ar raised to the power of n minus 2 plus ar raised to the power of n minus 1. That's equation 1. Equation 2 is rsn is equal to ar plus ar raised to the power of 2 plus ar raised to the power of 3, and so on until you get to ar raised to the power of n minus 1 plus ar raised to the power of n. This is equation 2. So these are two equations. So my goal is to get Sn. What is Sn? A formula that is suitable for you to find Sn. So what we will do now, follow this step. Subtract equation 2 from equation 1. Subtract equation 2 from equation 1. That's equation 1 is Sn, the Sn part. Then the equation 2 is the Rsn part. So we're doing the Sn part minus the Rsn part. So that's Sn minus Rsn. That's on the left hand side. On the left hand side, you have Sn minus Rsn. That's when you subtract. Then on the right hand side, I will not expand it because it will be too long to expand. So we will subtract it directly as it is now. We have a for the first part, for the equation 1, a, then plus open bracket ar minus ar. Now the first ar is from equation 1, then minus ar because we are using subtraction. The second ar is from equation 2. That's, let me say it again, a plus open bracket. The first ar now is from equation 1 minus the second ar in equation 2, then close bracket, plus ar is power of 2 from equation 1 minus the ar is to the power of 2 in equation 2. And so on until you get to ar is to the power of, in essence, what is it saying? Apart from this first a in equation 1, that first a in equation 1, every other term in equation 1, you can find it in equation 2. And what will happen is that they will cancel each other out. They will cancel each other out. So we have a plus open bracket ar minus ar plus open bracket ar square minus ar square, and so on. You also have plus open bracket ar raised to the power of 3 minus ar raised to the power of 3, ar raised to the power of 4 minus ar raised to the power of 4, until you get to ar raised to the power of n minus 1 minus ar raised to the power of n minus 1. Then in the first equation, there is no ar raised to the power of n. Ar raised to the power of n only occurs in the second equation, so you just put minus ar raised to the power of n. There is no ar raised to the power of n minus ar raised to the power of n. You only minus ar raised to the power of n. It's not going to be cancelled out by another ar raised to the power of n because it only appears in the second equation. So let me repeat what I have there. Sn minus Rsn is equal to a plus open bracket ar minus ar close bracket minus ar square minus close bracket plus open bracket ar square minus ar square, close bracket, and so on until you get to plus, open bracket, ar raised to the power of n minus 1 minus ar raised to the power of n minus 1 minus, close bracket, minus ar raised to the power of n. So all these brackets that are there, they are cancelling out because the terms they are equal but opposite signs. Ar minus ar is 0 is cancelling out. Ar is power of 2 minus ar is power of 2, they are cancelling out. Ar is power of n minus 1 minus ar is power of n minus 1, they are cancelling out. All the brackets that are existing will cancel out. But the only things that are remaining now is the first a and the last minus ar is power of n. So what you now have is Sn minus r Sn is equal to a minus ar raised to the power of n. On the right hand side is only a minus ar raised to the power of n that is left. So we perform factorization now. On the right hand side, Sn is common. You factorize Sn out. When you bring out Sn from Sn, 1 will be left. Bringing out Sn, so you have Sn open bracket 1 minus r. I'm getting r because when you bring out Sn from Rsn, only r will be left. So you have Sn open bracket 1 minus r close bracket is equal to, I'm factorizing a out from this side. A will be a open bracket 1 minus r raised to the power of n. I got 1 because when you bring out a from a, 1 will be left. I got r raised to the power of n because when you bring out a from a, r raised to the power of n, r raised to the power of n will be left. So what we have there is Sn open bracket 1 minus r close bracket is equal to a open bracket 1 minus r raised to the power of n close bracket. Now remember our goal is to find the sum of n terms, that's Sn. So to find Sn, I'll have to divide both sides by 1 minus r so that only Sn will be left on the left hand side. So dividing both sides by 1 minus r, 1 minus r will cancel 1 minus r on the left hand side, leaving only Sn. So Sn will be equal to a open bracket 1 minus r raised to the power of n over 1 minus r. So this is the formula for the sum of the first n terms of a geometric progression. So this is formula 1 for sum of n terms of a geometric progression. This is the first formula. So the second formula is similar to this. You can derive it in the same way, but we will not derive it. I'll just tell you the formula. But it's still the same process used to derive it. So in this part that we did, subtract equation 2 from equation 1. You can also do it the other way, subtracting equation 1 from equation 2. If you do it the other way, subtracting equation 1 from equation 2, you get the second formula, which is Sn is equal to a open bracket r raised to the power of n minus 1 close bracket all over r minus 1. The formulas they look alike. Actually, both formulas are the same. Both formulas can be used to solve any problem and you get the same answer. But the thing there is that the first formula is easier to use the first formula when your common ratio is smaller than 1. When you have a common ratio that's smaller than 1, it's easier for you to use the first formula. Although even though your common ratio might be bigger than 1, you can use the formula and you will get it. You get your answer correct, but just for simplicity of calculation, when your common ratio is smaller than 1, it's better for you to use your first formula. Then when your common ratio is greater than 1, you use the second formula. So what I'm saying is that Sn is equal to a open bracket 1 minus r raised to the power of n close bracket all over 1 minus r. You use it when r is less than 1. Then Sn is equal to a open bracket r raised to the power of n minus 1 all over r minus 1. You use it when r is greater than 1. So that is the formulas for sum of a GP. So that's the formula. So let's